Now we move on to the next rule, or the other rule for non-right angled triangles, and that's called the cosine rule. So obviously it's going to involve the cosine ratio. So where do we use this one? So we use the ratio where we have two sides and the angle between them. So if we've got angle sides B and C, we see, and we need angle A there. If we've got angle B or C, well, that's the sine rule. So we have that situation, then we use the sine rule. But if we've got the included angle, that's where the cosine rule is able to be used. The other way we use it is if we've got all three sides. If we've got all three sides and no angles, then we're going to be able to use the cosine rule in a form to find an angle. Sine rule needs an angle. So if there's no angles in your problem, well, you're automatically just going to the cosine rule, because the sine rule is not going to help you. So between the two, sine rule and cosine rule, we've covered every situation where the data could be given to us in a right angle triangle. Sorry, non-right angle triangle. So what are the rules? Again, the rules you can find the proofs for in your text or on the net. So if you're really that curious, you can have a look there. So I'm not going to produce that in this video. But how do we use that? Well, if we want to find this side C, okay, as we said, we need A and B, and we need that angle C. So to find side C, we'd have to have two sides and the included angle. And the rule would say that C squared would equal A squared plus B squared minus two lots of the product of A and B times cosine of C. So that's how we would use the rule to find that side. Now, if we want to find side A here, we'd swap A and C, and we'd have cosine in this one, and we'd have cosine of A. And if we wanted to find B, well, we'd swap B and C here, and have cosine of B. So really, whichever form you learn the cosine rule, it doesn't really matter. And some texts will have all three, depending on whether we're finding A, B, or C. But really, whatever side we're finding, that's going to be cosine of the opposite angle, and it's going to be the sum of the squares of the other two sides minus 2 times the product of the other two sides. Now, if we want to find cosine of C, so we want to find the angle C, as we said, we'd have A, B, and C. And then really, this rule is manipulation of this one. But what it comes down to is we'd have the A squared plus B squared, and it's minus C squared. So the way that I remember which side I know I'm going to add squares of two sides and subtract one. I'm going to subtract this opposite side to the angle I'm trying to find. So just be wary when we highlight this when we go through some problems. And that's over the 2AB like we had up there. Okay, so there's our rules we're going to employ. So we've got to remember to put those rules into play and apply those rules first up every time in a problem. So this time, we've got to find side of X, which is opposite 39 degrees, and we've got 22 and 39. So 39 degrees is what we call our included angle. It's been included between the two sides. So this means we're going to have to use the cosine rule. So we get x squared, 22 plus 39 squared, minus 2 times 22 times 39, times cosine of 39 degrees. Now, I'd put that straight into the calculator. Don't muck around with it. Don't try and be fiddly with it. Just put that straight in our calculator. Our calculators nowadays are really good at being able to do that. So they have no hassles. So put that straight in, and then we get an answer. Write that answer down, and making sure we have x squared, then we take the square root of both sides. So that's going to give us 25.91. Now, is that a reasonable answer? Again, we've got 22, 39x, so opposite 39, 25.91 sounds like a reasonable answer. The 671.42, well, that's what we had there. Does that sound reasonable? Well, could you have a triangle with 22, 39, and 671? I don't think so. That wouldn't be possible. So get rid of that one straight away. So that's not a reasonable answer. But we'd see that in our problem at some stage. So be really careful not to forget to take the square root and making sure we calculate this correctly, because some people will calculate those parts and they'll calculate this part and then do it in a few steps. Never do that. Put that all straight into the calculator and we get our correct answer. So the value of x in this one is opposite the 105. Now notice we've got 105 there. We can have an obtuse angle, not a problem. So if I'm looking at that, I'm going to expect my answer to be greater than 11 and 17, because that's the largest angle. So x should be larger than that. So when I look at these answers, D should be gone straight away. C should be gone because, well, it's going to be larger than 11 and 17, but not at the point where it's 506 millimeters. So C should be gone straight away as well. So we should be able to eliminate some answers because they're just not reasonable. Just won't make any sense there. So I'm down to these ones. So that makes life a little bit easier in a multiple choice. It's now 50-50 shot if you're going to guess, but hopefully we're not guessing. So we've got x squared. Applying the formula, 11 squared plus 17 squared, 2 times the 11 times 17 times cosine of 105. And we, again, put that straight into the calculator. Gives us the 506. So that's where you got your little tricky answer in there. But that's x squared is equal to that. We've still got to take the square root of both sides to give us 22.51. So there's our answer. Now, these ones are calculating the angle. So we're looking at the angle here. We've got theta on 10. But we've also got the theta's opposite 10. But we've also got the 8 and 9. No other angles. So we back to this rule here. So we have the 8 squared plus 9 squared. And we're subtracting the 10 squared. So remember what I said in the rules. The one we subtract is the one that's opposite the angle we're trying to find. So 2 times 8 times 9. And again, calculate that, or you could just take inverse cosine of all that, or just get your decimal. Inverse cosine of that one in degrees and minutes gives us 71 degrees 47 minutes. In the question here, before you even start, we should look at this one and go, well, 7, 15, 18, theta's opposite the 18, it should be the largest angle there. And it should be, by looking at that, well, we should take it to be obtuse, but it might not be obtuse, but we wouldn't be surprised if it is. So we're not going to rule out any answer yet, but keep that in mind that we should get the largest angle in the triangle. So it should be reasonably large, but it could be any of these still. So we calculate, we get the 7 squared plus 15 squared minus the 18 squared, because that's the opposite angle, over 2 times 7 times 15. Now when I do that calculation, we get a negative answer. That's okay. Don't panic that you get a negative answer. What does the negative mean with cosine? Hopefully we're all saying, wait on, second quadrant or the third quadrant. Well, we're not going to have an angle in the third quadrant because we only go up to 180 degrees. So we're not going to have a third quadrant, but it could be obtuse. It's going to be obtuse because it's negative. So once I get to that point, well, I can get rid of B and A it straight away because they're acute angles. So I know it's either got to be 98 or the 103. Again, put that straight into your calculator. You've got that in your calculator. Take inverse cosine of that, which shouldn't be a problem because it'll give you the obtuse angle straight away. Your calculator realizes that when it's got cosine, we're taking inverse cosine of a negative ratio, it's actually working with something in the second quadrant. So your calculator is set for that. So don't panic about having a negative answer there, then, because that will give you the obtuse angle that you need to get straight away. So in the next problem, so again we've just seen applications of the cosine rule. So the A is opposite the 115. So the 7 squared plus 12 squared minus 2 times 7 times 12. Show that application. That's going to get you marks straight away whenever you're doing an exam. That's going to get you marks straight away because you know the cosine rule. You've got to show that you know the cosine rule. And you don't know the cosine rule, then when you're in trouble. Do the calculation, take your square root. So the same thing there. You've applied the rule there. So do the calculation and then apply and then take the square root, and that will work out for you. we're seeing problems here where we're applying where we need to find the angle. Again, notice the two included angles are the ones we add, and we subtract the opposite angle. Get our numbers from there, get our decimal from the calculation, take inverse cosine, and get 61 degrees. Same thing, cosine theta, set up your formula, do the calculation, notice it's negative, expect an obtuse angle from there. And that makes sense because it's going to be a larger angle than the other two because 15 is the largest side. So let's have a look at a problem that involves the cosine rule. So we've got Alex in a game of rugby. He passes the ball 5 metres backwards to bin. He turns and kicks 28 metres towards Kerem. It's shown in the diagram here. So they've got the diagram. So it's 28 metres, 82, 5 there. We need to find the distance between A and C. So again, we've got two sides, included angle. That's the cosine rule. And notice that 82's there, so and 5 metres. So that one should be small. So it should be close to 82 again. So it should be close to 28. Because it's looking like an isosceles triangle. We're not told it's isosceles. We can't assume that. But we assume that 28 and AC would be close because that side's pretty small. And so we apply our cosine rule, get our calculations, and we get AC's 27.75 metres, or which is to the nearest centimetre. And that makes sense. That we looked at that and said, well, it should be close to 28. It looks very much like an isosceles triangle. But we didn't know that for sure. But it is pretty close. So this time, bearings question. We've got a helicopter. It leaves an airfield at a bearing of 295. So there's our 295 around there. That's where we got the 65 degrees. So it's 295 round to there. Travels for 38 and kilometers, and then travels at a bearing of 163. So that would be 163 around there for a distance of 46 kilometers. Find the distance between the helicopter and the airfield. So how do we get these ones? So 46 kilometers. So then we want to find X there. So with 295, so that leaves us 65 to go around to 360. So because that's 90 degrees there, and 163, so that should be from that part there to that part there. So again, we've got to really look at our interpretation. We're looking at that angle there being 163 minus 90, which gives us 73. Now, we know that's 65 degrees there, completely in there. So if we take, that's 73 degrees there. We know that's 17 degrees there. So, and that's 65 degrees in that one. So let's get rid of the 73 because that's not going to help us so much. We get rid of it all there. So we know that's 65 there. And because that was 73 there, we believe it's 17 degrees in that. So the 65 minus the 17 gives us our 48 degrees in our triangle there. So that's really the main part of the problem, is to try and find, we've got two sides, what angles can we get? So we weren't able to calculate this angle. We had a 65 degree, we can get that part of the angle, but we don't know this part of the angle. So the crux of the problem was finding that 48 degrees. So drawing our triangle up a little bit more neatly, we're able to see 46, 38, 48, and we want to find X. We know it's the cosine rule. So we apply the cosine rule, 46 plus 38, 2 times 46 times 38, gives us the times the cos of 48. Again, throw it straight in the calculator, get the 1,220.7194, and it'll keep going in your calculator, and then take the square root, and to the nearest kilometre, it's going to be 35 which sounds reasonable. Well, that's 48, so the other ones are opposite some larger angles probably. So it sounds rather reasonable to get that answer. So there we go. There's a bearings question where it comes out to be a cosine rule. Probably the hard part for most people is going to be interpreting that type of question to get a diagram and then deciding on whether it's going to be the sine rule or the cosine rule that needs to be played with. So there we go. If you're not sure about the cosine rule, which is probably a little bit harder than the sine rule, with a little bit more manipulation involved, keep going back and practicing, and hopefully by the time you have to do problems that involve both sine rule and cosine rule, then you're getting the hang of the cosine rule there.